Hello, and thank you for joining us. So, here we want to discuss some of the theorems associated with polynomials that can help us with factoring polynomials. It is important to distinguish the terminology used for determining factors of polynomials. If you're asked to use Ruffini's rule, right, then you must approach using synthetic division. If you're asked to use the factor theorem, then you must show that you're evaluating a polynomial. Also, sometimes in more advanced courses, they may say use Little Bézout's theorem. And that's just saying, hey, use the factor theorem, remainder theorem together, right? So if I evaluate a polynomial and the value is 0, then I know I have a root for the polynomial and I know I have a factor of the polynomial. However, if I evaluate a polynomial at some number and the value is not 0, then I know that I don't have a factor and I know the remainder upon division by my considered factor. So let's look at how we might apply it. All right. So the first one, use Ruffini's rule. So we have to do synthetic division. So I want to see, is x plus 1 a factor? So I'm going to set up with my -1, coefficient of x cubed, coefficient of x squared, coefficient of -1, and my constant. If I bring down the 2, multiply, add, multiply, add, multiply. There we go. So what does this tell me? From Ruffini's rule, I have a remainder equal to 1. So therefore, x plus 1 is not a factor. Okay. Now, I can double check this using other methods, see if my mathematics was correct, and I could really just come in here and say, hey, g of -1, well, g of -1 is going to be -2 plus 1 minus -1 plus 1, which is equal to 1. And so once again, I can see that I have a remainder of 1. X plus 1 is not a factor. But this approach in blue, this would be using the factor and the remainder theorems, which tend to be easier in most cases, also known as Little Bézout's theorem. So for A, I would have to do the work in red. Okay, so let's look at B. B does say to use the factor theorem to determine if g of x equals 2x cubed plus x squared plus x plus 1 has x plus 1 as a factor, right? And so that is where we say, hey, well, g of -1 was equal to 1. Therefore, x equals -1 is not a root, and therefore x plus 1 is not a factor. Okay, so important to distinguish. And lastly, find k such that x plus 2 is a factor of x cubed plus x squared minus kx minus k. All right, so if I let f of x equals x cubed plus x squared minus kx minus k, then x plus 2 is a factor if f of -2 equals 0. Okay, well, what would be f of -2? F of -2 would be -8 plus 4 plus 2k minus k. And that needs to equal 0. And that will equal 0 if -4 plus k is equal to 0. So therefore, if k is equal to 4. So factor theorem, remainder theorem tends to be easiest to use because you're just evaluating. It's important that we understand how these items get applied, and that if needed, you're always asking questions for clarification. Thank you very much for your time.